Kia ora, Year 12. This video is going to go through the achieved questions from last year's Level 3 differentiation paper. So in question 1a, we're told explicitly that we don't need to simplify our answer, and we've got a straightforward product rule question. So dy by dx is going to be equal to the first function, e to the 3x, times the derivative of the second one, which will be 2 cosine of 2x, right, because of how the chain rule works on this function. So the inside function here is 2x, plus the other way around, the derivative of the first function, which will be 3e to the 3x, times sine of 2x. Okay, so in both cases what we're doing there is we're doing the chain rule. The first chain rule is on sine of 2x, and the second chain rule, differentiation, is on e to the power of 3x. So if you're watching this and you don't understand how to use the chain rule, go back and watch some of the teaching videos that I've done on that on the Level 3 differentiation playlist, or send me an email. Okay, the next one is a graph question where we have to look at the properties of a function. And this used to be often a merit question where you had to get like 4 out of 6 correct, but they've changed it last year, and so this is just worth achieved, which I feel like is actually a bit fairer. So here we've asked to find the values of x, or the value of x, that meets the condition that the gradient is equal to 0. There are 2 places that this happens. The gradient's equal to 0 along here, and the gradient's equal to 0 here. One thing to watch out for is that at the kind of corner point here, the gradient's not defined. Right, so the gradient is only defined where the curve is smooth. That's what it means for something to be differentiable. So we just have to be careful with our inequalities. The first place where the gradient is equal to 0 is where x is strictly less than 2, and the second place is where x is equal to 4. Next, we have to figure out where f of x, where the function is concave upwards. So concave upwards is what's happening here up to here. And again, we have to watch out for our endpoints. Concave upwards is asking a question about the second derivative. Right, so we're saying, where is the second derivative? Positive. But the second derivative is only going to be defined where there's a first derivative, and at both this endpoint and this one, there's no gradient. So we have to again watch out for the inequality signs, and the answer here will be that x has to be between 3 and 6. Now the last question in here is asking, what's the value of the limit of the function as x goes to 7? So we have to look from both sides and see if it's approaching the same number. And in this case, you can see that as we're approaching 7 from below, we're heading towards a y value of 3, and as we're approaching 7 from above, let's try that again. When we're with x values that are approaching 7 from below, the y value is heading towards this value here of 3. And the same thing's happening when our x value is coming in from above 7. We're heading towards a y value of 3. So that means that the limit does exist, and that the limit is 3, even though the function at 7 has a value of 5. Right? So the value of the function when x is 7 is not the same as the limit, but the limit exists because it's heading to the same place. All right, let's go on to question 2. So question 2 is yet another chain rule question where we don't need to simplify our answer. We've got an inside function, which is 1 minus x squared, and we've got an outside function, which is something to the power of 5. So f dash of x will be 5 times 1 minus x squared to the power of 4 times negative 2x. And that's all we have to do. We don't need to simplify our answer. In question 2b, we have to find the x-coordinates of any stationary points on the curve. So when I'm looking for stationary points, I'm looking for places where the gradient is equal to 0. And in this case, that's all I have to do. Differentiate, find the gradient, and solve where the gradient is 0. So dy by dx here we can find using the quotient rule. I'll start by squaring the denominator, x plus 1 squared. I'll copy it up the top, and I'll multiply by the derivative of this. So that's 2x minus the other way around, the derivative of the denominator, which is 1, times the numerator. That gives me 2x squared plus 2x minus x squared divided by this. And that has to equal 0 for a stationary point. For something to equal 0, we just need the numerator to be 0. So that gives me the requirement that x squared plus 2x is equal to 0. And x times x plus 2 equals 0. So either x equals 0 or x equals -2. All right, let's just check that we don't have to do anything else. Yep, that's all we had to do. We just had to find the x coordinates of any stationary point, so we didn't have to put it all the way back into the curve. In question 3a, we have another quotient rule, and it's got a trig derivative in it. So I've put in the table from the formula sheet. You can see that when we differentiate the cotangent function, we get negative cosec squared x, and we need to know that for this one here. Again, it's just a straightforward quotient rule. I'm not giving you the formula for the quotient rule. I figure by now you probably know it. If you don't, you haven't done enough practice with these questions. So it is in the formula sheet, but we should just know how to do these. So we're going to square the denominator, x squared plus 1 squared, copy it up the top, so that's v. And now we differentiate our numerator, and that will give me negative cosec squared x. And it says we don't need to simplify our answer, so now we're going to keep going. We're going to work the other way around, so we differentiate the denominator. Minus 2x times cot of x. I'll just check that that's, yeah, that really is all you need to do for that one. Okay, so we've found the gradient function, and we can go on to the next question. So in the next one, we again have to find a stationary point. If you just look at the achieved questions, this actually feels kind of repetitive, right? But we're finding a stationary point, and we have to find the coordinates. So this time we do have to find the y value. The function itself, though, is pretty easy. So the function is y equals 4x to the 1/2 minus x plus 2. dy by dx, which we're going to set equal to 0, is 4 times 1/2, so 2x to the -1/2 minus 1. And that has to equal 0 for a stationary point. That gives us 2 over root x is equal to 1. So 2 is equal to root x. So x must equal 4, squaring both sides. So that's good. We've found the x value. Now we need to find the y value. So y will equal 4 root 4 minus 4 plus 2, which is equal to 8 minus 4 plus 2, which gives us 6. So the stationary point has coordinates 4, 6. Okay, so that's us done for the achieved questions. I will come back and do some of the merit ones later on this weekend. Thanks for watching. Let me know if you've got any questions that you especially want videoed.